I'm Dr. Jim Zobel. You're about to watch one of my video lectures. If you like this video and would like to get videos for your entire General Organic and Biochemistry course, you can do so at www.collegechem.com. I'll give you more information about that at the end of this video. The quality of the equipment used to make a measurement is one factor in obtaining accurate and precise results. The ability of the human operator to correctly use the measuring device is another factor. One way to include information on the precision of a measured value, or a value that's calculated using measured values, is to report the value using the correct number of significant figures. These videos are made to be viewed while using fill-in lecture notes. The pause in the audio is to give students time to complete the lecture notes fill-in. The lecture notes can be downloaded, free of charge, at www.collegechem.com. The precision of a measured value can be determined by the rightmost decimal place reported. For example, let's consider the precision for the number 869.257. The names and precision of the decimal places for this number are shown in the view graph. Notice that the precision increases as you move to the rightmost digits. This number is precise to the thousandths place. A simple way to understand significant figures is to say that a digit is significant if we are sure of its value. Let's consider an example of an old tree. Let's say a botanist reports that a tree is 500 years old. If we actually know that this value is precise to plus or minus 1 month, that means that all the digits in the number are indeed known and the number has 3 significant figures, the 5 and both zeros. But what if the reported age of the tree is only precise to plus or minus 10 years? In this case, the only digit we truly know is the 5. The 2 zeros are just there to keep the 5 in the hundreds decimal place. In this case, there is only one significant figure. Let's now take a look at how we can write the number 500 using one significant figure or using 3 significant figures. In this course, and throughout your professional career, both measured and calculated values should always be reported with the correct number of significant figures. I'm going to give you a method for counting the number of significant figures in a given value. Don't worry if you don't completely understand these rules the minute I utter them. I'll help you develop your own understanding of these rules by working through some problems with you. We could look at a numerical value and determine the number of significant figures using the rules that follow. If the decimal point is present, that means you see a decimal point written there. Starting from the left, count all numbers, including zeros, beginning with the first non-zero number. If the decimal point is absent, in other words, you don't see a point written there, starting from the right, count all numbers, including zeros, beginning with the first non-zero number. When numbers are given in scientific notation, don't consider the power of 10, only the value before the times 10 raised to some exponent. Let's do a couple of problems using the 500-year-old tree that I discussed earlier. If the botanist reported that the age of the tree was 500 years, written as shown, how many significant figures are given? Note that although the decimal point is implied to be after the rightmost zero, it's absent. It's not shown explicitly. Therefore, we use the decimal point absent rule, which is, if the decimal point is absent, starting from the right, count all numbers, including zeros, beginning with the first non-zero number. We'll start inspecting each digit going from right to left as shown by the arrow. We start counting when we get to the first non-zero number. We don't count the first 2 zeros, but start counting at the 5. Therefore, there is one significant figure present. The 2 zeros are only present to keep the 5 in the hundreds place. Now let's try another example. If the botanist reported the age of the tree as 500 with a decimal point, how many significant figures are given? Note that in this case, the decimal point is present. It's shown explicitly. Therefore, we use the decimal point present rule. If the decimal point is present, starting from the left, count all numbers including zeros, beginning with the first non-zero number. We'll start inspecting each digit from left to right as shown by the arrow. We'll start counting when we get to the first non-zero number. We begin with the 5, then count all numbers including zeros. In this case, the zeros are also significant. Therefore, there are 3 significant figures in this value. Outside of science fields, the number 500 with and without the decimal point are generally thought of as equivalent. However, the use of significant figures tells us that when we write 500 with the decimal point, we know that the digit in the ones place is 0, not a 1, 2, 3, 4, 5, 6, 7, 8, or 9. We also know that the digit in the tens place is a 0, not a 1, 2, 3, 4, 5, 6, 7, 8, or 9. This implies that the method or device used to obtain this measured value was precise to the ones place. We don't know the values of any of the digits that would occur to the right of the decimal point. When we write the number 500 without showing the decimal point explicitly, this implies that not only are we unsure of the numbers to the right of where the decimal point would appear, we're also unsure of the value in the ones place and in the tens place. The only value that's significant is the 5. This implies that the method or device that was used to obtain this value was not precise enough to determine the value at the ones place or the tens place. When we write the value 500 using a decimal point, we know the number 100 times more precisely than we do when we write the number 500 without the decimal point. When 500 is written with a decimal point, it is precise to the ones place. When the number 500 is written without the decimal point, this implies that the precision is only to the hundreds place. The zeros are needed to keep the 5 in the hundreds decimal place. An educational goal for this chapter is for you to look at a value and determine the number of significant figures. Let's do a few examples together. In the first problem, we'll determine how many significant figures are contained in the number 0.00045. Note that this number was written with the decimal point present. Therefore, we'll inspect the numbers from left to right. We'll start at the first non-zero number and we'll count every number, including any zeros that may be present, after that. This number has 2 significant figures, the 4 and the 5. For the next example problem, let's figure out how many significant figures are contained in the number 0.0002600. Note that this number was written with the decimal point present. Therefore, we'll inspect the numbers from left to right. We'll start at the first non-zero number and we'll count every number, including any zeros that may be present, after that. Note that in this problem, 2 of the zeros are significant. The reason for this is once we reach the first non-zero number, all the numbers are significant, including zeros. This number has 4 significant figures. For our next example problem, we'll determine how many significant figures are contained in the number 7080. Note that this number was written with the decimal point absent. Therefore, we inspect the number from right to left. We start at the first non-zero number and then count all numbers, including zeros, after that. This number has 3 significant figures. The rightmost zero is present only to keep the 7 in the thousands place, the other 0 in the hundreds place, and the 8 in the tens place. If the rightmost zero was not present, the number would be 708, not 7080. Before I have you look at some values and determine how many significant figures are present, I want to show you a little trick that you may find useful in remembering the rules and the method for counting significant figures. Think of a map of the United States. To the west we have the Pacific Ocean and to the east the Atlantic Ocean. In our mental picture, we'll use the P from Pacific Ocean to represent decimal point present and the A from Atlantic Ocean to represent decimal point absent. Then, as we apply our rules for significant figures, we'll inspect numbers in the direction from the ocean to the land, depending on whether the decimal point is present or absent. Remember to inspect the digits in a value in the direction from ocean to land. In order to do so, thinking about the theory of evolution will be helpful. In the theory of evolution, land-dwelling species evolved from species that were originally in the ocean. These species evolved from ocean to land. This is the same direction that you'll inspect numbers when using this mental picture. So when the decimal point's present, we inspect a number going from left to right. In our mental picture, that's the direction from the Pacific Ocean to the land. We count all numbers, including zeros, beginning with the first non-zero number. When the decimal point's absent, we inspect a number going from right to left. In our mental picture, this is the direction from the Atlantic Ocean towards the land. Moving in this direction, count all numbers, including zeros, beginning with the first non-zero number. Now you try some problems. Specify the number of significant figures contained in each of these values. Click pause and work on the problem now. Check your answers. In part E, the decimal point is absent, so we start inspecting from the right and go to the left. We start with the first non-zero number, which is the 2, and every number after that, which is the 6. In part F, we have the same 4 digits as we had in part E, 6200. However, in part F, the decimal point is present. Therefore, we start inspecting the number from left to right. We start counting at the first non-zero number and count every number, including zeros, after that. This number has 4 significant figures. In part H, the decimal point is present, so we start inspecting the number from the left and move to the right. We start counting at the first non-zero number and count every number, including zeros, after that. In this case, the 0 to the left of the decimal point is not significant. Its purpose is to draw attention to the decimal point. In the medical field, this 0 is often referred to as the safety 0. The reason for this is that it adds an extra measure of safety when reading the number. For example, if this value represented a dosage, and the healthcare worker did not see the decimal point, 6,200 units of a medication could be administered instead of 0.62 units of that medication. To find the number of significant figures in a value that's written in scientific notation, don't consider the power of 10, only the value before times 10 raised to some power. I'll elaborate on this by doing a few examples. How many significant figures are contained in each of the values shown below? We only consider the value before the power of 10. These values are shown highlighted in red in this view graph. 5 times 10 to the second has 1 significant figure. 5.0 times 10 to the second has 2 significant figures. 5.00 times 10 to the second power has 3 significant figures. Note that it's not possible to write the number 500 in regular notation using 2 significant figures. If the decimal point is present, the number 500 would have 3 significant figures. If the decimal point is absent, the number 500 would have 1 significant figure. The only way to write the number 500 with 2 significant figures is to use scientific notation. You can get your entire general, organic, and biochemistry course as a series of video lectures. The rental period is for 1 year, so you'll have these video lectures for the entire term of the course. You could watch the videos whenever and however many times you wish. I survey my students and they prefer these video lectures over the textbook by a ratio of about 10 to 1. Fill-in lecture notes and an electronic version of my textbook are available free of charge at the website. To get more information or to get the videos, free textbook, and free lecture notes, visit my website at www.collegechem.com.